All right, I'm gonna try to fix some issues I found in the last video. So if I try to run it, so it only runs for one time. So there's something wrong. So let's get rid of the weight group and see if it works as expected. Also, I'm gonna like remove the go routine from here. So let's see if it. Okay, weight group. So where are we calling WG? Okay, here. I'm just going to get rid of this import and see if it works without that. Okay. Okay, we're back to square one. So if we call this go routine, we need to add go, like we need to add first let's get the weight group, import it real quick. Also let's pass that. Okay, now we got the weight group. This needs to be a pointer. So I'm gonna put this, I'm gonna launch the crawl in a go routine. So where are we calling the go routine? So the first crawl. So we need to add this at the beginning. So we add one. Let's also run this with go. And here we call done. And every time we run a crawl, we need to call weight group done. Where are we supposed to call the weight group done? So probably right here, I think. Weight group add one. Okay, let's see if this works. I don't know like what's going on. So a few things are wrong here. You never call wait. Okay, let's fix that. Okay, now let's run it. Okay, body. Okay, it was really fast. So we basically completed it, but these coroutines are accessing a map. So this is all the things the coroutines uh, execute, but they also you know look access the map. So this can be a problem. Concurrent map access, this is the big one. Multiple coroutines are reading and writing. So we got a map and we are reading from the map, and we are getting the value from the map at the same time. So there are two places where we read from the map. Go maps are not thread set. You will eventually get uh, fatal error, concurrent map read and write, but we didn't get that. So that doesn't mean it won't happen. It will happen eventually. So we need to create a safe map that holds this map. So let's create that. So let's create type safe map, which is a struct. This holds a mutex sync, uh, mutex, and a map of string and result. So we have a safe map now, and then what else? SMU. What is this? SM. So we need to get the instance of the safe map, and then lock, call the lock, and then unlock whenever we try to read it. Even with the mute text, this can happen. Coroutine A calls the reads from the map. If it doesn't contain the key, then C is not visited before it adds it. Coroutine B also C is not visited. Now both start crawling the same URL. You need the check and mark operation to be atomic, something like. So we have a lock. Okay. So we get OK. Then we unlock it. So if visited is okay, we unlock and return. Visited visited URL is empty. Unlock. If it's okay, we unlock it. If it's not okay, we also unlock it. Before fetching, you are marking visited after fetching. Current flow. So we fetch the URL, we get body URL's error. If it doesn't exist, we do something. Two coroutines can fetch the same URL simultaneously. Usually crawlers do check visited, mark visited, unlock. So only one coroutine check. So only one coroutine fetches each URL. Depth check should happen before spawning. This isn't breaking anything because This doesn't break anything because you check at the start of crawl, but you're still creating coroutines that immediately return when depth is 0. Not a huge deal. What the goto teaches here, but it is this safe visited struct. So it needs that safe map. So let's go to main. So visited. Let's create safe map. Safe map. Safe map as I believe. What does it have? It does a map. Which is this empty? Safe map as property M, which is this empty result map, but visited map. So fake map. So I have a fetch method and fake map. Okay, cool. That takes so somewhere here fake map. So we are supposed to like take a map, the fake map, a fake map, fake result. All right, so this is something like the safe map is for visited map. So visited safe map. Visited safe map and fake map are different. Safe visited safe map. Pass a map. All right. Instead of safe map, let's say I want to pass. Let's pass safe map, which is a type of safe map. Also, let's get rid of this. So that's the visited map. So visited map, let's get rid of that. Here, let's use safe map. Get rid of this and put it at the end. Safe visited safe map. So now we got safe map. Okay, we need to pass the pointer, not the value. So here, so whenever we access the map, like here, so we need to use the safe map M, safe map M, valid operation. Okay, so wherever we use the safe map, we need to use wherever we use map, we need to use safe map. So I don't see any error. So now wherever we access the safe map, we need to safe map mutex lock, and then we need to safe map mutex unlock. and here safe map mutex lock mutex unlock. So we protected the map read using lock. So what happens is that when if two coroutines are trying to read this simultaneously, they wait. And there's a place where ChatGPT tells me to unlock. Right, where is it? So we are doing the same thing. So we are okay. So we are checking if the map contains the URL. If it doesn't contain the URL, we push the result. We fetch the result and push the result. C is not visited before it adds it. C is not visited. Algorithm B. C is also not visited. Check and mark operation to be atomic. So visited if the so one go routine. So this is the line we are protecting. This is the code, right? We access. So we're trying to check whether the URL exists in the map, and if it exists, we unlock it. So any go routines that checks for this code immediately gets it, I think. I don't understand this, bro. Like, is our current implementation good enough? Is this good? What's wrong? You're closer, but there are still a few bugs. One of them is nasty deadlock. You forgot to unlock before continue. If we is already visited, executes and skips the unlock, the mutex stays locked forever. Then every other routine trying to extend the map blocks you need. I need to unlock here before I skip. Mutex unlock. Okay. Still as a race condition. Imagine two coroutines discover the same URL simultaneously. Coroutine A. Okay, sees. We check the map, returns okay if it's exit. If it's not okay, means the map doesn't contain the URL, so it's not visited. Coroutine is also not visited. Both launch. Now the same URL is crawled. Okay, I pretty much don't understand why this is causing race condition. So this whole block is protected, right? So let's imagine two coroutines access this, and get the fuck out of here, bro. Two coroutine access this. First coroutine access this block. Checks. There is no URL in the map. Um, so there's no URL in the map. If there's no URL in the map, it adds the result. So this whole thing is adding the result. So like before everything even starts, I just fetch the URL. So every Go routine, the first thing they do is call the URL. So we need a way. Where are we calling the Go routine? We need a way to we need a way for the Go routines to not visit the same URL. I mean, it seems like everything is fine, but so this is the URL. So I mean, just ignore this URL because we are not adding this to the map of visited URL. The reason it kind of like took some time is that when I run, it takes some time to initialize it. Now it's fast. Still as a race condition. Imagine two routines discover the same URL simultaneously. C is not visited. Routine B. Okay. My logic doesn't depend on whether the URL is not in the map. So first we visit a URL, and then we get the URLs in that main URL, right? So here we check if it exists. If it exists, then we continue. So if there's already like a URL in the map, we don't even launch the Go routine. So this is the whole code. So this is my logic. If there is a URL in the map, we skip everything. We skip the loop. So let's imagine two Go routines are checking the map. Two Go routines are checking the map and thinks the what the fuck is this? Let me just URL is in the map visited. So when two Go routines access this code, maybe the map could be in a partial state. When one Go routine visits, the map might not contain that URL. And when another Go routine accesses the map, the URL might be in the map. So we need to think in terms of like multiple read access. So let's say two coroutines read this, and if there's a URL, it continues. And also this is the write operation. This is where I protect the write operation. If there is no URL, I add it. So only one coroutine can add URL. One coroutine is adding the URL. Another coroutine is reading the map, reading whether the map contains the URL. Kind of hard to wrap your head around. God damn this goofy motherfucker. Problems. One go routine is adding a result if there is no URL, and it's got result. One go routine is accessing map and checking if the map contains the URL. If it is, it skips fetching it. Mark visited before fetching. Right now happens before assignment. So duplicate coroutines can fetch the same URL. Usually crawlers do. If visited is true, unlock return. Mark visited, unlock. That way only one coroutine ever fetches a URL. Result, storage becomes weird. If you mark visited early, you cannot immediately store because you don't have the body yet. Like don't understand what you are saying. Let's walk through a real example because the bug is easier to see than explain. Deadlock. You wrote lock, unlock. If the visitor is, so if the map contains the URL, we continue. Suppose we have a URL and it's already in the map execution. So mutex locked, jumps to the next loop iteration. Notice what never happened. Okay, this is okay. We fixed that. Same URL crawled twice. Imagine coroutine A, coroutine B, both discover fmt package at the same time. Checks if it exists in the map. Okay, false, not visited. Before A starts the new coroutine, coroutine B checks if result. Okay, false, not visited. Now both do. Now you have crawl fmt running twice. Why? Because you only mark visited after fetching. Okay, this is the bug. We only mark visited after visiting. So this doesn't prevent a coroutine from even like fetching. So for a brief moment, URL is being crawled, but not marked visited. So this is the critical moment. When we have this moment where if we have ton of coroutines and some weird coroutine finds this moment, URL is being crawled and it's not being visited. So the map so the map doesn't mark the URL, so the map doesn't contain the URL. And when two coroutines simultaneously access it, so the usual solution, the first thing inside crawl, so there is a URL in the map, unlock it and return, and then mark as visited. And then unlock again. Now coroutine A gets here first. Why? So if there is a wait a second. So this whole thing is locked. If there are two coroutines, if there is one coroutine, it gets a lock. It runs this code. So there's a URL returns. If there is no URL, so the first thing it does is marks as visited. So the first thing it does when the URL is if it doesn't contain the URL, it marks as visited in the lock and then unlocks. Marks as visited arrives later because it can only arrive later because it holds the lock. So it arrives later. That lock guarantees sees it already exists, immediately exits, only one coroutine fetches. So this is it. Although it doesn't immediately add the result, it just makes it so it already fills it with some garbage or whatever. So it marks this as visited. It's not the actual visit, but it will eventually add the result later, but it just marks it as visited. Only think of map as a notebook. Your current core code, go to website, read website, write website in notebook. Correct crawler, write website in notebook, go to website, read website. Okay, so this is what we are doing. We're going to website. That's annoying logic. So what we are doing is, so we are fetching the URL. Then after fetching it, we basically add it. We store it. So we need a way to indicate that we're going to the website. So the thing we can do here, if there is no so the current logic, okay, let's just add URL is not in the map. Okay, first, okay, let's do something. If okay, let's read the map. Do I need even? We read the map, and then so let's for a second. Two coroutines have the say arrive here and check the map and see there is no URL in the map. What the? So if there is no URL, what we gotta do is URL is result empty. So we are trying to mark it lock, and then unlock. So this is the if block. So if it is if there's already visited, then we need to return. Okay. So unlock, and then so let's see, else, let's put else block. Let's put this unlock here, and then return. Let's copy this and ask ChatGPT. Okay. How about now? That's much closer. The beginning is now doing the important thing. Suppose two coroutines arrive simultaneously. Lock, check map, not found. Insert result, unlock. Coroutine waits for the lock, and then lock, check map, found, unlock, return. Okay. Only one coroutine continues to fetch. Perfect. But now there's a new issue. Remember what happened earlier? You already inserted. So now it's always be false. The URL is already in the map, therefore never runs. Your map only contain for every URL. Instead do no need to check. So we are checking here, and then since there's already URL in the map, so there's already in the map URL not in the map. So this code only assigns value if the URL is not in the map, but there's already URL in the map, so this code never runs. So we don't need this check. So now the access, although this kind of seems unnecessary, is this lock even necessary? I don't know. Okay, let's ask ChatGPT now. Now is this good? Much better. The duplicate crawl problem is basically solved now. Is this lock even necessary? Yes. Why? Because another coroutine might be doing okay at the exact time. Wait a minute. So where is the lock? Basically another coroutine might be doing access. Even though only one coroutine writes to a particular URL, multiple coroutines are still accessing the same map concurrently. Go maps require synchronization whenever there is a concurrent writes or write read combination. Without the lock, you will eventually get concurrent map read and map write. Only one thing you can simplify: this check in the loop isn't actually necessary. And why? Uh, because the beginning of our crawl already does return. So we already return it. So you can simply do add and crawl. If a URL was already visited, the new goroutine immediately returns. This is actually the cleaner concurrent design. Tiny edge case. Suppose body returns an error. You already inserted before fetching. So the URL remains marked as visited forever. That's not necessarily wrong. Only many crawlers do exactly that, but it's something to be aware of. So, yep. Since we already return, if there is, so basically there's a URL in the map, so we return. So this check here, we don't need that. We don't need this check here. All right, let's crank this up. Let's crank this up a bit more. So we got a fake map. Let's see. We need a way to generate turn off links. Maybe a JSON or something. Give me the setup. If you want to trust your crawler, manually writing hundreds of URL is pain. A simple approach is to generate a fake web graph programmatically. Tree-shaped graph. Each page links to a few child pages. Um, mm, 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 mm. Okay, let's use this number of pages. Okay, I'm gonna copy this. It doesn't really matter what this is. We just need a way to generate fake random maps. So fake map, let's get rid of that, and in that place, fake map. Okay, and then we need to use this generate random web. So text, number of pages, links per page, 5 fake map. So make fake map so empty fake map. So URLs creates a slice of num pages. So adds the URL is doing something like, what is this? Quick fix import rand. So it's generating ton of map. Let's see. All right. It needs an initial map. I'm using this. Like, what's the initial page. With fake map, page generate 0 all the way. So your starting page should be one of these, page 0. That was really fast. Okay, that's with, wait a minute. That's with go routines. Let's remove all the go routines. So we skip. Okay, before we, okay, let's copy this. Solved crawl, go. Okay, let's remove all the weights and shit. So weight group, remove them, remove this. So yeah, weight group, remove that, and remove this. Okay, seems like we got everything. Also, let's get of go. I mean, even without go routines, it sleep. It's we need to add a sleep. We need to add sleep to indicate take some time. So where is the fetch method? Where is the fetch? Fetcher, result, safe map, crawl, fake map, fake fetch. Okay, here. Let's use time. Sleep. This is 20 millisecond. Okay, now it's much slower. Now we need to add them back. To differ. Sync. Weight group. Weight group. And then like where we're launching the go routine. So here we are adding go routine. We add the go routine. We call add and then we call done. Okay, let's see. Now this is much faster. Okay, let's copy this. let's create hello to go. So this is gonna like give us an error. Because we have the same like main function. Okay, let's just undo everything. So is this everything? Yeah, it is everything. So much slower. And this is much faster. So there are so many things going on here. I don't even want to read this again, bruh. So what did we learn here? Okay, so the first thing is we need to use the sync weight group correctly. Although I didn't use the, so what is this? We didn't, wait a minute. We didn't even use the go routines. Could it be that's the reason? So we are using the hello, okay. We are using the time. Why is one faster and the other is not? So this is faster, why? Oh, here we are using go routine. Although we didn't use the go routine here. So where do you use the add method? Like you're keeping track of go routines, bro. So every time you launch a go routine, you need to add one if you want to track that go routine. Wait for that go routine. As for you need to wherever you read the map, you need to lock it. You need to use the mutex using the struct. You need to get the mutex and use that mutex to lock and unlock wherever you read the map. So there's a tiny chance when two routines read the map and the URL doesn't exist, and the URL does not exist, go routine launches, but before it assigns the result and to the URL to mark it as completed, another go routine can also read the same URL and see that it doesn't exist, and it can also run. So this part is kind of hard to explain and understand. So we just mark the URL as completed. You could probably use a array or something. So you can use an array to put all the URLs that's being processed and then pop that URL, right? So let me ask ChatGPT what it thinks. What if we used a array to put processing URLs and every go routine check that to avoid duplication. You could, but an arrest list is usually actually worse than a map for this job. When a Goroutine wants to know if page is already being processed, it must scan the whole slice. That's some goofy time. With thousands of URLs, that's slow. A map is effectively a set string bool check with that's approximately time. In fact, your current solution is already acting as both visited set, processing set, because the moment you insert, you're saying somebody is already handling this URL. Other routines see it and return. If you wanted to separate the concepts, you'd actually do safe crawler processing. Then if processing URL or visited URL is true, then unlock fetch. Then after it, after you complete that fetch operation, you delete um, processing with the URL. This lets you distinguish processing currently being fetched, visited already finished, which is useful for a rail crawl, but for the simplest and your current crawler, the simplest thing is exactly what you are already doing. Insert immediately URL reserved. So that's pretty much it. A bit complicated, but we got this done.